In April of 2016, San Francisco Regional Rail Network, called BART, had begun experiencing massive failure of their electric trains. One after another, their trains would fail on a certain section of the track, and BART couldn't figure out why. After losing 85 trains, BART finally concluded that the cause of the problem were high voltage transients. Amazingly, BART never figured out what was creating these transients. Mysteriously, and fortunately for them, the transients just went away. But this example illustrates how damaging the transients could be to anyone who is connected to the grid. Hundreds of thousands of people were stranded, and BART spent millions on repairs, and since the problem was never resolved, it can come back any day. In this video, we're going to demonstrate to you the equipment that can be used to detect these transients and talk a little bit about what creates these transients in the first place. This is our local utility power line waveform. Right now it has no significant distortion, no spikes, no transients, and no noise. And ideally you want this waveform to always be like that, but just like in case of BART, this power line waveform is affected by many factors, and they are out of control of utility customers most of the time. So you can have disturbances on this power line. And right now we're going to demonstrate these disturbances because we had connected this oscilloscope to a machine called transient generator, which is specifically designed to test the electronic products for immunity against the power line spikes and transients. You just saw one of those transients. And as you can see, these transients in amplitude are higher than 120 volt, and therefore if you plug in something in the outlet with this kind of spikes, equipment can get damaged or destroyed. In real life, these spikes are not created by generator, they're created by many other sources, and those sources are very common. They exist in large quantity in any modern society, and we're gonna show you how easy it is to generate those spikes with everyday equipment. Modern urban environments are full of large electric motors. They run street transport like trams and subways, operate elevators, they operate trash compactors, garage doors, pumps, HVAC systems, and every one of these motors is a potential source of transients when they fail or if they're not properly operated. Also, whenever you connect and disconnect conductors and you witness electric arc, you are witnessing creation of a voltage transient. So right now we're going to go and try to create our own transients. This is an electric drill press. It has a pulley connected to the drill bit, and it's driven by a motor of 0.3 horsepower, okay, and it's powered by 120 volts, and we're going to use this simple device to demonstrate how the transients gets created. Okay, so we're going to start the drill press, okay, and we're going to jam the drill bit so the motor stops spinning, or at least try to jam the motor, and let's see what's going to happen with the AC power line. Okay, we jammed the motor. By overloading the electric motor, we made the line voltage jump up instantaneously, and our scope was able to capture this event. Here's our transient, and the best part about capturing this transient, operator didn't even need to be in the room. Once the scope was set up, it detected it on its own and saved it in memory. Now, before you run out there and spend a fortune on an oscilloscope, let's discuss the features you actually need to be able to capture events like we did a minute ago. The must feature for the scope to have is a single event triggering. Without that feature, you won't be able to capture random events, period. Most oscilloscopes out there are powered by AC 120 volt or 220, depending on which country you live in. And that creates a problem when you try to probe live AC circuits, because the probes of the oscilloscope are not isolated. The regular probes are connected directly to the outlet that powers the oscilloscope. for grounding purposes. So if you confuse or unable to identify the hot and the neutral, you will create a short circuit that will either damage the equipment you're probing or it will damage your oscilloscope. So therefore, you should consider getting a portable battery operated scope like the one you see here. This scope has single event triggering, it's battery powered, it's also a multimeter and the actually voltage recorder, and it's also very rugged and built specifically for field work in unfriendly environment. However, this scope also has its limitations. The maximum voltage that this scope can safely measure is 600 volts, which could be actually lower the threshold of the transients you are trying to measure. The solution to the limitation of maximum voltage measurements is using differential high voltage oscilloscope probes. Those probes can measure voltages up to 5,000 volts. The additional advantage of those probes is they don't require oscilloscope isolation. You can use AC powered oscilloscope and not to get a short circuit through the ground because these probes themselves are isolated. The only thing is to be careful about is to make sure the probe you are getting is compatible with the scope you have or will get. Usually these are not cross compatible from one brand to another, so you want to stick with the same brand for the probe as the scope. So Tektronix probes works with Tektronix scopes. Another type of oscilloscope probe that can be used to look at power line waveforms is a clamp-on current probe. Those probes do not require direct physical contact with energized circuits. They measure through insulation. However, they have disadvantages that they are sometimes difficult to fit where you want to get the measurement, and also they measure only through a single conductor. In addition, some of them require amplifiers. So one more thing to carry. But in certain applications, they will be actually easier to use than other type of probes because you won't need a physical contact with energized circuits. If you feel you are ready to take on tough troubleshooting jobs in the field and all you need is some test equipment, please visit equiptech.com. We sell a variety of refurbished test equipment. Equiptech labs have been in business for 30 years and we're located in San Francisco Bay Area. We also offer consulting services.